Hey everyone, Hassan here. Welcome to our video on number system formulas. You know that feeling when you're facing a complicated math problem, and it feels like deciphering a secret code? We've all been there. Today we're going to crack the code together. We'll break down key formulas step by step with easy-to-understand explanations and examples that will make you say, aha, now I get it. So whether you're just starting out or need a quick refresher, stick around, and you'll be surprised how straightforward these formulas can be. Let's dive in. Let's start with a simple yet powerful formula, the product of square roots. The square root of a product, like 16 times 25, is equal to the product of the square roots of those individual numbers. So instead of multiplying 16 and 25 first, we can take the square root of each number separately. The square root of 16 is 4, and the square root of 25 is 5. And look at that, 4 times 5 gives us 20, which is exactly the square root of 16 times 25. Remember, this formula works for any two positive numbers. Next up, we have the square root of a quotient. This formula tells us that if we have a fraction under a square root sign, we can simplify it by taking the square root of the numerator and dividing it by the square root of the denominator. Let's take an example, the square root of 49 over 9. Instead of calculating the square root of the entire fraction, we can take the square root of 49, which is 7, and divide it by the square root of 9, which is 3. So, the square root of 49 over 9 is simply 7 over 3. Much easier, right? Now let's talk about conjugates and how they simplify expressions with square roots. Imagine you have two terms, each a sum of a whole number and a square root, like the square root of 9 plus the square root of 4, and the square root of 9 minus the square root of 4. When we multiply conjugates, the middle terms cancel out. In our example, we get 3 plus 2 times 3 minus 2, which simplifies to 5 times 1, and that equals 5. Don't let the long name intimidate you. This formula is just a fancy way of saying we're squaring a binomial that involves square roots. Let's break down an example, the square root of 5 plus the square root of 3 squared. Squaring something means multiplying it by itself, so we have the square root of 5 plus the square root of 3 times the square root of 5 plus the square root of 3. This gives us the square root of 5 times the square root of 5, which is 5, plus the square root of 5 times the square root of 3, which is the square root of 15, plus another square root of 15, and finally the square root of 3 times the square root of 3, which is 3. Combining like terms, we get 8 plus 2 times the square root of 15. Remember the difference of squares we talked about earlier? Well, the product of conjugate surds is another form of that, except now we're dealing with square roots. Let's say we have the square root of 6 plus the square root of 2 times the square root of 6 minus the square root of 2. When we multiply these conjugates, the middle terms cancel out. This leaves us with the square root of 6 times the square root of 6 minus the square root of 2 times the square root of 2, which simplifies to 6 minus 2, and that equals 4. We've arrived at our final formula for today, the difference of squares. This is a fundamental algebraic identity that you'll encounter frequently. The difference of squares tells us that if we have the product of two binomials with the same terms but opposite signs in the middle, it simplifies to the square of the first term minus the square of the second term. For example, let's take 7 plus 3 times 7 minus 3. Using the formula, we get 7 squared minus 3 squared, which is 49 minus 9, and that equals 40. That's it for today's video on number system formulas. We've covered a lot of ground and broken down some seemingly intimidating formulas into manageable concepts. If you found this video helpful, please give it a thumbs up, share it with your friends, and subscribe to my channel for more math made easy. I'm eager to hear from you. Would you like me to explain more formulas related to exponents, logarithms, or any other specific topic? Let us know in the comments. See you in the next video.